Hi everyone, our lesson today is exponential function, differentiation and integration. First part, differentiation. So we'll have a quick revision on differentiation. First, number one, if f of x equals c where c is constant, then f dash equal 0. For example, f of x equal 4, so f dash equal 0. Number two, if f of x equal x power n, then f dash of x equal nx power n minus 1. For example, f of x equal x power 4, so f dash will be equal 4x power 3. Number 3, if f of x equal g of x power n, then f dash equal ng of x power n minus 1 times g dash of x. For example, f of x equal 3x power 2 plus 5x minus 1 all power 4, f dash of x will be equal 4 times 3x power 2 plus 5x minus 1 all power 3 times 6x plus 5, which is the derivative of the bracket. Number 4, if f of x equal g of x plus or minus r of x, then f dash will be equal g dash plus or minus r dash. For example, f of x equal 5x power 2 plus 2x plus 7, so f dash will be equal 10x plus 2. Number 5, if f of x equal g of x times r of x, then f dash will be equal g of x times r dash of x plus r of x times g dash of x, which is the first times derivative of the second plus the second times derivative of the first. For example, f of x equal x power 2 plus 3 times 2x power 3 minus 5. F dash of x will be equal x power 2 plus 3 times 6 power 2, which is the first, times the derivative of the second, plus 2x power 3 minus 5 times 2x, which is the second, times the derivative of the first. Finally, if f of x equal g of x over r of x, f dash of x will be equal r of x times g dash of x minus g of x times r dash of x over r of x square. So we'll have f of x equal 3x minus 4 over 2x plus 5. F dash of x will be equal 2x plus 5 times 3 minus 3x minus 4 times 2 over 2x plus 5 all power 2, which will finally will be equal 23 over 2x plus 5 all power 2. Differentiation of exponential function. Derivative of natural exponential function. Let be a differentiable function of x. Number 1, d over dx e power x equal e power x. Number 2, d over dx e power u equal e power u times du over dx equal e power u times u dash. Example number 1, find the derivative of f of x equal e power 2x minus 1. Let u equal 2x minus 1, then u dash equal 2. So f dash of x will be equal e power u times u dash equal e power 2x minus 1 times 2, which is the derivative of 2x minus 1, which will finally will be equal to 2e power 2x minus 1. Number 2, f of x equal e power negative 3 over x. Let u equal negative 3 over x equal negative 3x power negative 1. Then u dash will be equal 3x power negative 2 equal 3 over x power 2. So f dash of x will be equal e power u times u dash equal e power negative 3 over x times 3 over x power 2 equal 3 e power negative 3 over x all over x power 2. Example number 2. Find the relative extrema of f of x equal x e power x. To get the relative extrema, find the x values for which the first derivative is 0. So our first derivative will be equal x e power x plus e power x times 1 equal, we will take e power x as a common factor, so we'll get finally e power x times x plus 1. Because e power x is never 0, the derivative is 0 only when x equal negative 1. Example number 3. The standard normal probability density function. F of x equal 1 over square root 2 pi times e power negative x power 2 over 2. Prove that this function has point of inflection when x equal positive and negative 1. To get possible point of inflection, find the x values for which the second derivative is 0. So our first derivative will be equal 1 over square root 2 pi times negative x. Negative x is the first derivative of negative x power 2 over 2. Okay, so we'll get negative x times e power negative x power 2 over 2. Important to note here that 1 over square root 2 pi is constant. So our second derivative will be 1 over square root 2 pi times negative x times negative x times e power negative x power 2 over 2 plus negative 1 times e power x power 2 over 2. We will combine negative x and negative x to x power 2. So we'll get 1 over square root 2 pi times x power 2 times e power negative x power 2 over 2 plus negative 1 times e power x power 2 over 2. We will take e power negative x power 2 over 2 as a common factor. So we will get 1 over square root 2 pi times e power negative x power 2 over 2 times x power 2 minus 1. So the second derivative of x is 0 when x equal positive and negative 1. Second part of our lesson today is integration. So before we will get a revision on integration. Number 1, integration k dx equal kx plus c, where k is constant. For example, integration 5 dx equal 5x plus c. Number 2, integration k f of x dx equal k integration f of x dx. If we have constant times function of x, we can move the constant outside the integration. For example, integration 2 e power x dx is the same when we move the 2 outside the integration. So we'll have 2 integration e power x dx. Number 3, integration x power n dx equal x n plus 1 over n plus 1 plus c. For example, integration x power 5 dx equal x power 6 over 6 plus c. Number 4, integration f of x plus or minus z of x dx is the same if we make the two function all in separate integration, equal integration f of x dx plus or minus integration g of x dx. For example, if we have integration x power 2 plus 5x dx is the same equal integration x power 2 dx plus integration 5x dx. Finally, integration f dash of x times fx power n dx equal f of x times n plus 1 over n plus 1 plus c. For example, integration 2 plus 2 e power x all power 3 times e power x dx. Note that e power x is the derivative of the bracket. So we will remove e power x and make integration on the bracket only. So our integration will be 2 plus e power x all power 4 over 4 plus c. Integration of exponential function. Integration rules for exponential function. Let be a differentiable function of x. Integration of e power x dx equal e power x plus c. Number 2, integration e power u du equal eu plus c. Where du equal u dash times dx. Example number 1, solve each of the following. Number 1, integration e power 3x plus 1 dx. Let u equal 3x plus 1, then du will be equal 3 dx. Okay, we divide and multiply by 3. Why 3? Because our derivative of 3x plus 1 is 3, so we divide and multiply by 3. So we'll get 1 over 3 integration e power 3x plus 1 times 3 dx. Then we substitute u equal 3x plus 1. So we'll get 1 over 3 integration e power u du. Then we make integration, so we'll get 1 over 3 times e power u plus c. Finally, we back substitute, so we'll get e power 3x plus 1 over 3 plus c. Number 2. Integration 5x times e power negative x power 2 dx. Let u equal negative x power 2. Then du will be equal negative 2x dx. Okay? So to convert 5x to negative 2x, we will divide multiply by negative 2 over 5. Okay? So we will get negative 5 over 2 integration 5x times e power negative x power 2 times negative 2 over 5 dx. We simplify, so we will get negative 5 over 2 integration e power negative x power 2 times negative 2x dx. Negative 2x is the derivative of negative x power 2. Okay, substitute u equal negative x power 2, so we'll get negative 5 over 2 the integration e power u du. After that we integrate, so we'll get negative 5 over 2 e power u plus c. Finally, we back substitute, so we'll get negative 5 over 2 times e power negative x power 2 plus c. Note that we can only introduce number 2 integration like 3 and negative 2 over 5, like we did in the previous two examples. However, remember that we cannot introduce a missing variable factor in integration. For example, integration 2e power x power 2 dx is not equal 1 over x integration 2e power x power 2 times x dx. Number 3. Integration e power 1 over x power 2. Let u equal 1 over x, then du will be equal negative 1 over x power 2. So in this case we will divide and multiply by negative 1. So we will get negative integration of e power 1 over x times negative 1 over x power 2 dx. Then substitute u equal 1 over x. We will get negative integration e power u du. After integration, we will get negative e power u plus c. Then we back substitute. Finally, we will get negative e power 1 over x plus c. Number 4. Integration 1 plus e power x all power 2 dx. We will expand the bracket. Then we will get integration 1 plus 2e power x plus e power 2x plus e power 2x dx. After integration, we will get x plus 2e power x plus 1 over 2e plus 1 over 2e power 2x plus c. Example number 2. Find the area of region bounded by f of x and the x-axis for x is greater than or equal 0 and smaller than or equal 1. Number A. F of x equal e power negative x. B. F of x equal e power x over square root 1 plus e power x. Area for number A. Integration from 0 to 1 f of x dx equal integration from 0 to 1 e power negative x dx. Okay, we divide and multiply by negative 1, so we'll get negative integration from 0 to 1 negative 1 e power negative x dx. After integration, we will get negative e power negative x integration from 0 to 1. We substitute x 1, then substitute x 0. So we'll get negative e power negative 1 minus negative 1 times e power 0. Finally, we will get 1 minus 1 over e, which will be equal 0.632. Area for number B. Integration from 0 to 1 f of x dx. So we'll have integration from 0 to 1 e power x over square root 1 plus e power x. U will be equal 1 plus e power x. Du will be equal e power x du. Okay. We flip the denominator to numerator by change the power of sign. So we'll get integration from 0 to 1 plus e power x power negative 1 over 2 times e power x dx. Note that e power x is the derivative of the bracket, so we consider e power x is not existent. We will integrate the bracket only. So we'll get 1 plus e power x 1 plus e power x all power 1 over 2 over 1 over 2 equal to square root 1 plus e power x integration from 0 to 1. So we will substitute, then we will have 2 square root 1 plus e minus 2 square root 2, which will be equal to 1.028. Thank you for today.